Hello everyone. Today we will go over the 2026 Cayley Contest hosted by the University of Waterloo. So for problem 1, we have what is the value of 13 plus 15 plus 17? So it doesn't really matter the order in which we add these, but I'm going to go with 17 plus 13 just so we get a nice even number like 30. And then here we add 15 to get 45. So this one will be B. Number 2, the number 1 million is, and then we need to choose the scientific notation. We can write 1 million as 1 followed by 6 zeros, and so this will be equal to 10 to the power of 6, since each power of 10 adds another 0 at the end. For problem 3, we have if 4x plus 1 equals 13, what is the value of 12x plus 3? So we could use this equation to solve for x and then substitute it in, but we could also notice that the expression 12x plus 3 is really just 3 times our original expression. And so now we don't even have to solve for x. So this will be equal to 3 times 13, which is 39. Here we have number 4. So in the diagram, the number line between 0 and 6 is divided into 12 equal parts. The numbers m and n are marked on the line. The value of n minus m is. So here we can notice that since the 12 equal parts add up to a sum of 6, each equal part has length 6 equals 12, which is 1/2, or 0.5. So now we just need to count the number of gaps between m and n. So here we have the first one, second one, third, and so on. And then we can count 7 total gaps. So now we see that n minus m is the length of those gaps, which is 7 times 0.5, which gets us to 3.5. Next, we have problem 5. Carly went for a run on May 18th. She did not go for a run on May 19th. She continued to alternate going for a run one day with not going for a run the following day. Between May 18th and May 25th inclusive, how many days did she go for a run? So here, since the numbers are relatively small, we can just count it. So she went on a run on the 18th and then not on the 19th. Since she alternated, that means she went on the 20th, 22nd, and 24th. So here, if we just count these, we see that she went on a run 4 days. Next, problem 6. Jin has 40 cupcakes, 75% of which are chocolate, and the rest of which are vanilla. If Jin wants to bake more vanilla cupcakes so that half of the cupcakes are vanilla and half are chocolate, how many more vanilla cupcakes should Jin bake? So first, we need to compute how many chocolate cupcakes there are. So we see that chocolate is equal to 75% times 40. And this is equal to 3/4 times 40, which is equal to 30. So now the remainder needs to be vanilla, so 40 minus 30 equals 10 vanilla. So now, since there are 20 more chocolate than vanilla, then Jin has to bake 20 more vanilla so that half are vanilla and half are chocolate. And so she would need to bake 20 more. Now we have problem 7. Which of the following integers has the same remainder when it is divided by 3 as when it is divided by 4? So here we can just make a table to catalog these. So here we have number, we have remainder 3 and remainder 4. And here up top we have 9, 11, 10, 13, and 8. So for the remainder, when divided by 3, 9 has a remainder of 0, 11 has a remainder of 2, 10 with 1, 13 with 1, and 8 with 2. For remainder, when divided by 4, 9 has 1, 11 has 3, 10 has 2, 13 has 1, and 8 has 0. So now looking at this table, the only number where the remainder of 3 and 4 match up is 13. And so that is our answer. Now for problem 8, if the point Q 4, 2 is shifted left 5 units and then down 6 units, the result is point R. What are the coordinates of R? So here we need to draw the coordinate plane, and we have Q right here. So now if we shift it left 5 units, then we will have, let's say, P, and since it's shifted left 5 units, the x coordinate will be 5 less. So it'll be 4 minus 5, which is negative 1. And then now we shift it down 6 units. So then when we get R, the y coordinate will be 6 less. So 2 minus 6 is negative 4. And so here, R will be negative 1, negative 4. So it will be A. For problem 9, the edge lengths of a rectangular prism are integers. 3 of its faces have areas 12, 20, and 15 centimeters cubed, respectively, and we want to find the volume. So we could use these to solve for the individual lengths. So let's say let them be L, W, and H. So we could solve for it since we know, let's say 12 equals LW, 20 equals LH, 15 equals WH. We could solve for L, W, and H individually, but since we want the volume, there's actually a really nice trick here. So if we multiply these equations, we get 3,600 is equal to LW times LH times WH. So if we square root this, we get 60 equals LWH. And this happens to be the expression for the volume, so we're done. And so the volume is 60. Finally, for problem 10, a Nelson card has a number on each side. 3 Nelson cards lie on a table as shown. Jen flips the cards one by one, flipping the 3, then the 7, then the 8. Each time she flips a card, the mean of the 3 visible numbers increases by 1. What number is on the opposite side of the card with the 8? So let's let the variable be average before, be the average before she flipped the 8. And then we have average after. So since these all have 3 numbers in the average, if we multiply by 3, we'll get the sum. And so since average after is equal to 1 plus the average before, we know that sum after, since we multiply by 3, is equal to 3 plus the sum from before. So since the only change we're making is flipping the 8, we know that after flipping the 8, the sum needs to increase by 3.